Hello, let me start the presentation. Before we solve the problem, let's take a quick look at continuous random variables and PDF. When random variable large X takes all the values within an interval, large X is called a continuous random variable. Then look at the graph. The left side is continuous and the right side is discrete. The discrete random variable large X is specific to the value that can be taken, but the continuous random variable takes countless values. Then let's look at the probability density function. First, large X is continuous random variable if there is a non-negative function fx, and the PDF is a value that indicates the magnitude of the random variable. Therefore, to obtain the probability between A and B is to obtain the width of the PDF graph. So we use integral because we get the width of the graph, and must also have the normalization property this. Finally, large X is continuous, so it is possible to this. Now, let's solve the problem. Between 15 and 20 minutes if the day is sunny, and between 20 and 25 minutes if the day is rainy. Since these two intervals contain all possible driving times, the PDF should be 0 everywhere else, where C1 and C2 are some constants. And assume that a day is sunny with probability 2 divided by 3 and rainy with probability 1 divided by 3. We can determine these constants by using the given probabilities of the sunny and of the rainy day. So the C1 is 2 divided by 15 and C2 is 1 divided by 15. In terms of graph, the width of the PDF graph is probability, and the sum of the probabilities was then confirmed to be 1. Generalizing this example, we can see the PDFs as Ci and divide it. Ci means if small x is between ai and ai plus 1 and I is 1 to n minus 1. 1 minus 1. 1 minus 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 and already know the integration of PDFs from A1 to AN is equal to the sum of each area, and that is 1. Thank you for watching my video.